So this is the rectangular prism we're going to speak about. I've seen in some textbooks they call this a cuboid, but I don't know, guys, but you get it. Okay, this is the rectangular prism that I'm talking about. So it is a three-dimensional shape that has your length, which is generally the longest side facing you. Then you have your breadth, which is the one going away from you. And of course, your height is how tall your shape is. So let's get started over here. Surface area is the area of the outside faces of the prism. Okay, so I want to know, if I were to paint this shape, or if I were to cover it with something, how much of that material would I need? And in order for you to know that, you need to know how big the shape is, don't you? So this is the shape, right? I put the second one here so that you can generally see how many faces we actually have. So how many faces does a rectangular prism have? Let's hear. It's important for you to understand this. How many faces, how many faces would this shape have? Thank you, Dumi. It has 6 faces, right? It has 6. And generally, you usually have 2 that are exactly alike. It's possible to have more than 2, but generally, we would have 2 that are generally alike. What I mean is, if you look at the rectangle in the front base, it would be exactly the same as the one at the back. Do you guys agree with that? The one in front, exactly the same at the back. And then the one at the top would be the same as which one? The one at the top would be the same as which one? The one at the bottom. Thank you very much, Seth. So this area over here of the rectangle at the top of your shape would be the same as the one at the bottom, which is over there, which leaves the last 2, which is the one on the right and the one on the left, which will be exactly the same. Now, as long as you understand that, you understand how to work out surface area. This is called a net, right? This is called the net of the shape. We just basically unraveled it before. Just pretend this is before you fold the box up and close it. This is what it is. So we have already identified we have 6 faces, A, B, C, D, E, F. And the way they numbered them, they numbered the ones that are the same consecutively. So A would be the same face and dimensions and everything as B. Okay. And then C would be the same dimensions and size as D. And then E, which is actually the one at the bottom, would be the same as F. Because imagine if you were closing this, you would fold this upwards, and F would end up being the top face. All right. So to work this out, this is the general formula of a rectangular prism that is closed. Emphasis on that is closed, because it is not always closed. Do you guys agree? That is not always the case. But this is the formula for one that's closed. Now let's see what's going on here. So it says 2 times length times breadth. What does that remind you of? What area does that remind you of? Besides the 2, let's just talk about the length times breadth. Not a square, but remember, for square, we say length squared because it's the same thing, right? So for square, we would say the area is L squared. The area of a rectangle, which is what we have. All of our faces here are rectangles, okay? So let's see. Length times breadth. So that would be the longer side that way times this side that's coming forward or going backwards. So that's the area of the top rectangle. But how many of those did we say we have? How many of those that are just like the top rectangle did we say we have? We have 2, which is why we multiply by 2. Do we see that? So you say 2 times the area of this one, because it'll also give you the one at the bottom. And then plus 2 times breadth times height. Let's see which one that accounts for. Breadth times the height. So that accounts for the two rectangles on your side. It's these ones. It would be the one on the right-hand side and the one on the left-hand side. But again, there are two of them, which is why there is a 2 in the front of that formula. And then finally, you have 2 times length times height. And if you look where length times height takes you, that will be the front one. So your front rectangle and the one at the back. Okay, so it would be this guy and the one at the back. Again, there's 2 of them, hence the 2 in front. Does this formula make sense? This is for a complete closed rectangular prism. Can I have a thumbs up on this formula? Do you guys see where it comes from? Okay. Some of us, most of us see where it comes from. Great. Now, I actually want us to work out the surface area of this rectangle that we can see here. Okay. So then you would say, then surface area, which is what SA is, that is not for South Africa, that is surface area, is equal to 2 times length times breadth. So that would be 13 times 5 plus 2 times breadth times height. So that's 5 times 7 plus 2 times length times height. So that's 13 times 7. Now let's get working out here. Now, I know when you guys use your calculator, sometimes things go south. I don't know what happens there, but you end up with the wrong answer when you have the right working. So to avoid that, just work out the little pieces on its own and add at the end. How's that? Okay, so you say 13 times 5, which is 65, and you times that by 2, so that is 130, plus 5 times 7, which is 35, times 2, which is 70. And I'm going to need help with the last one. What is 13 times 7? Let's get our calculators out. 13 times 7. That is 91. And if you times it by 2, that is 182. Thank you, Lorianne and Seth. And my final answer will then be the 182 plus 70 plus 130. And what is my answer here? 382. Now, what are my units? What are the units in this case? Let's hear what you guys have to say about the units. Anya says meters, and so does Dumi. Seth says meters squared. Okay. What does everybody else think? There are at least 12 of you in here. Let's hear what you have to say. What are my units for surface area? They are indeed meters squared. Now, it's a bunch of areas together, but it is still an area. Do you see that inside the brackets, the 2 doesn't have units? Do we all agree with that? The 2 is a constant. It doesn't have units. So here you have meter times meter and another meter times meter and another meter times meters. And then when you end up adding, this is already meter squared plus meter squared plus meter squared. Does adding affect your exponents? Does adding affect our exponents? No, which is why we end up with an answer of meters squared. Can we get a thumbs up, thumbs down on the calculation and units? Wonderful. Wonderful. Okay, now let's move on to volume and capacity. Does anybody know what the difference between volume and capacity is? Before I show you the definition for capacity, does anybody know the difference between volume and capacity? Anyone? Volume and capacity. Volume is the amount of mass an object possesses, okay? Capacity is the space inside. Okay, you guys are sort of correct. Yes, okay. So volume would be how much space does this shape occupy? If I had a box, an empty box, and I had to place it somewhere in the house, I need to know how much space this thing is going to occupy. Do you guys agree? But capacity is if I want to fill that box with stuff, how many or how much can I put in there? And it's usually liquid. Does that make sense, guys? So think about your bottles, your water bottles, your what other bottles are there in the world? All of that. Your mugs even have capacity so that you know how much tea am I drinking, how much coffee am I drinking, and all of that shenanigans. Okay. So volume is the amount of space a three-dimensional shape takes or occupies. So for volume, think about storage, right? Think about storage. Where would I put this thing? Where would this box fit in the house? And for volume, you have to take, okay, I have a problem with this general formula, but this actually just works for a, there we go. This works for a rectangular prism, but what's usually the one that they give us in the formula sheet? Does anybody know? There's a different one that they give us in the formula sheet for volume. That counts for every single shape. And what is that? Does anyone know? If you're at the boot camp, you should know. Volume is equal to, anybody remember? Yes, Seth. Yes. Okay. So this will generally count for, yes, it counts for a rectangular prism. But I want you guys to remember volume as the area of whatever the base is. Okay? Times the height. Do you guys agree that it will be easier to remember one formula instead of 7 when we start doing different shapes? Isn't it just easier to remember it? And because in this specific case, our base is a rectangle, then yes, it will be length times breadth, but it will not always be length times breadth. You guys get what I'm saying? So it's the area of the base times the height. In this case, we are working with a rectangular prism, so that is correct. All right, but get into the habit of doing this, area of base times height, because then if your base is a circle, for instance, then it's no longer length times breadth. And if your base is a triangle, it's no longer length times breadth. Just say area of base times the height. Okay, which formula are we using? So, Seth, this is how I would generally write it if I was writing in a paper. Right? Okay, no, there are no three-dimensional shapes here. I'm disappointed. But let's say, Seth, that you have a triangular prism or a cylinder or a rectangular prism. Right? Those are 3 different shapes. My first step where I write volume equals, I will always write area of base times height for all of them. Are you with me, sis? And then in the next step, I'll say, okay, because it's a triangle, that means this part is half base times height. But if it's a cylinder, it is pi r squared, because that's the base, times height. But if it's a rectangle, it'll be length times breadth times height. Do you see that it's a lot of formulas to remember? But if you just know that it is your area of the base times height, then you're fine. Does that make sense, Seth? I'm not saying you're throwing out the other one and using the one. I'm saying just start over here, because you never know what happens in a test when you're just stressed. So it's just easier to remember one formula. So whatever the base is, if it's a triangle, use the formula for a triangle. If it's a rectangle, use the formula for a rectangle. If it's a cylinder, use the formula for a circle. Okay. Okay. Now capacity, as I said, is the space that is inside. So think of storage. Okay. Think of storage. You're welcome, Seth. You're welcome. So volume, how much space does it take? Capacity, how much stuff can I put inside? So how much water can this container hold? All right. Now, this is one thing that makes you guys lose so many marks because we forget. Capacity has to be either in milliliters, liters, or kiloliters. Do not leave it as centimeter cubed. All right. And certainly don't leave it as meters cubed. You always have to convert to one of these. Usually the question will tell you which one, so you don't have to worry about that. And these two guys are what you call conversion factors. But this is the easiest conversion I've ever seen in my life, guys, because 1 milliliter is equal to 1 centimeters cubed. So if I say to you, I have a box that is 250 centimeters cubed, how many milliliters is that? Let's see if you understand this. Thank you, Seth. It is 250 milliliters. Do you see? It's a conversion factor, Andile. There we go. Okay, this is the same as 250 milliliters. Do you see how easy this is? It's a one-to-one comparison. And in the same way, 1 kiloliter is equal to 1 cubic meters. So if I say I have something that is 1,257 meters cubed, how many kiloliters will that give me? How many kiloliters will that give me? That'll give me the same amount, isn't it? It's 1-to-1. So it will be 1,257 kiloliters. Done. Okay. Now, the only time it gets complicated is if you're working with liters and you have to convert between. But you did do a lesson with Teacher Coco on conversions, right? Do you see why it was important to do that before? This was the very reason why it was important to do the conversion lesson before, just to remind us how to get from one unit to the other. So let us get practicing. Okay. Calculate surface area and volume of the following. Now, today's lesson is titled rectangular prism. So you know that everything you're going to get after here is a rectangular prism. But later on, we're going to mix up the shapes a little bit and see what happens. Okay. So I'm going to start off by calculating volume. Okay. So I said V is equal to, tell me what the formula for volume is again that we spoke about. The one that is safe to use all the time. Which one is it? Area of base. You can't say base. You must say area of base times height. The reason you can't say base, Seth, is because in your stress, you're going to use 15 as the base because base usually speaks about two-dimensional shapes. You guys agree? So can you imagine you're in a test and you wrote base times height, and now you're looking at this and you're like, what? This can't be right. 15 times 5. No. Do you see what I mean? So area of the base times height. In this case, a base is a rectangle. So then its length times the breadth times the height, which is 15 times 7 times 5. Let's hear What is the volume of this shape? Okay, I'm going to get working out as well. Please check me because you know I make mistakes sometimes, especially when it comes to using calculator. Guys, I can get a lot of things right, but I don't know what happens when I take out a calculator. Thank you very much. I got the same answer, 525. Now, what is my unit for volume? My unit for volume, it is not meters squared, it is meters cubed. And again, let's look at the logic here. How many dimensions are we multiplying? This is meters times another meters times another meters. Okay. Now let's move on to surface area. We know the surface area of a rectangular prism is 2 times length times breadth plus 2 times breadth times height plus 2 times length times height. Now, if you forget this whole thing that I am doing here in a test and you just sort of blank out and you just forget, just make sure you don't repeat sides. That's it, right? Make sure length is multiplied. Look there. Length is multiplied by breadth and height. Done. Breadth is multiplied by length and height. That's done. And your height is multiplied by breadth and length. Do you guys see what I mean? So just make sure that you don't duplicate any of these and you are fine. Okay, it's not a train smash, don't worry. All right, so let's get multiplying 2 times, and my length is, okay, so I do this. I don't know if you guys do this, but I color code my stuff because then I don't multiply stuff that I'm not supposed to multiply with each other. And your height is 5 meters. I know some people make a little key for themselves, like on the side they'll write L is 15 and then just substitute from this. So whichever one works for you, do that so that you don't get confused and suddenly you multiply 7, but you said length. Okay, so this is 15 times 7 plus 2 times 7 times 5 plus 2 times, where's the length? 15 times 5. Okay, let's get working, guys. Let's get working. First one, 15 times 7 times 2. I got 210 for the first one. Plus 7 times 5 times 2. That is a 70. Plus 15 times 5 times 2. That is a 150. Okay, final answer. Does anybody have the final answer? Thank you very much. Wandile and Seth. 430, and yes, meters squared. All right, can we have a thumbs up, thumbs down, guys? How are we feeling about this one? I love paper 2 stuff. I don't know if you guys feel the same or I'm just weird. But I love paper 2. Okay, let's move on. Okay, so now we have another one here, but what is the problem? That's what I've always thought, Seth and Andile, but a lot of people disagree with me. A lot of people prefer paper 1. I don't know why. Yes, Seth, the units are different. Okay, units are different. How do we convert millimeters to meters? Millimeters to meters. I'm going to write here. It's going to be 10,000. First of all, am I dividing or am I timesing? Let's see if we know our conversions. Will I be dividing or timesing? Divide, yes. And millimeters means I divide by? Not 100, but 8,000. So do me, here's a trick I used to remember, right? A century is how many years? If I say to you, it's been a century, it's how many years? How many years am I talking about? You guys should know that. A century. Does anybody know how long a century is? You guys don't know how long a century is. Oh my goodness, I'm shocked. Thank you. To me, it's 100 years. Okay, so the prefix cent means 100 because centimeters you divide by 100. You see what I mean? Because a century is also 100 years. So that's the only way I can remember the stuff. Otherwise, I have no idea whether it's 100 or what. I'm always confused. Okay. So all you remember is meters is always in the middle. Meters is the original, it's the OG. Okay. Meters is the OG. And then if you're going backwards to centimeters, and then to millimeters, and then you can go this way to kilometers as well. So to get to the century, it is 100. Okay. And then to get all the way there, it is 1,000. Who knows what kilo means? Now I'm afraid to ask because you guys just show me flames now. Kilo is? Anybody? Oh! Yes, it's 1,000 to me. It's 1,000. Wow. What a different guys! You guys are gonna do physics next year. You're gonna have to learn nano and micro. So I suggest you learn this stuff now. There's gonna be more coming. You're gonna have to learn all of this stuff. Okay. So asseblief toch, asseblief. But just remember century, 100 years. Done. Great. Now let's convert. What's 10,000 divided by 1,000? You'll be fine, guys. It's not that bad. Just learn the stuff. Okay, you'll be fine. Oh, Andil already told me the answer. Thank you. So this is 10. So it's equivalent to 10 meters. Great. Now we can do what we are here to do. Firstly, this time I'm gonna start with surface area. Okay, surface area, again, 2 length times breadth. Does it matter which one I put first? What if I say length times height plus 2 breadth times height? It doesn't matter, okay? It doesn't matter if breadth times height is first and then length times breadth is there, and it doesn't matter. Okay, E equals. Now let's identify our length quickly. What is my length for this one? My length for this shape. That's definitely not your length. It could be, but that's confusing, right? 20, it's the longer side. The longer side on the flat side, okay? My breadth is the 10 meters. And the height, guys, just think of normal height from the ground up. Do you see height is more suited to be 4 meters? Hi, Lorianne, did you get kicked out? It's okay, you're back. What matters is you are back. Okay, welcome back. All right. And someone else just got kicked out. I don't know what's going on, guys. Maybe it's a network thing. Okay, so let's get substituting. Okay, I did all of this and then I didn't. I'm gonna do this just to avoid problems. 20, B is 10, H is 4. Great. So length, 2 times length times breadth, which will be 20 times 10, plus 2 times length times height, plus 2 times breadth times height. Isn't this easier, guys? They gave us such nice round numbers. This is 2 times 200. So 400 plus 2 times 80, so 160, plus 2 times 40, so 80. It's a very nice teacher who did this, ne? Okay, so what's my final answer? Thank you, Seth. 640 and Bongumusa meters squared. All right, and let's do volume quickly. Now, I'm gonna spice up volume, but let's first just do volume. So volume is area of your base times the height. And our base is still a rectangle, so it's still length times breadth times height. So you're just multiplying everything you have basically. 20 times 10 times 4. So that is how much? 200 times 4. So that's 800. Can we check? Thank you very much. 800 meters cubed. Huh. Now I want this. I want you guys to convert this to a capacity in milliliters. Now it's going to shake. How are we going to get there? Is there a conversion factor that involves meters squared? Oh, there is. There is. I was trying to be slick. But I can't be slick, but it's fine. So it's 800. So this is how you write it. So you'll say 800 meters cubed is 800 kiloliters, but I asked for milliliters. And how do you get from kiloliters? I forgot the K. How do you get from kiloliters to milliliters? That haunting guy again, which is called conversions. Hey, do you know how to get from milliliters to liters? Maybe we should take it slowly. Do you guys know? Okay, I'm going to do this. I'm going to say liters. And I'm going to put the side kiloliters because that's bigger. And this side, I'm going to put milliliters. Now we're going backwards, right? Starting over here. There we go. Now, how am I going to go from kiloliters to kilo? What did we say kilo is again? We just spoke about it. When we spoke about kilometers, it's 1,000. Now, am I dividing or am I timesing? I'm going from the bigger units to the smaller. Am I dividing or am I multiplying? We're dividing. Thanks, Butlali. We're dividing. So let's take 800 kiloliters and divide by 1,000, please. Let me work that out. 800. That's just 0.8, isn't it? Yes, that's 0.8. And now we're at liters. Now, again, I'm going to the smaller units. So am I dividing or timesing? If I'm going to the smaller unit, I am dividing again. And we just spoke about this. Milliliters. Milli is what? How much is it? Divide by what, guys? Let's see if anyone is actually going to know this. No, guys, there's only one that's 100, and that's centimeters. Milli and kilo are both 1,000. Okay. Milli and kilo are both 1,000. And the only time we divide by 10 is to go from centi to milli. But we don't have a centiliter. I've never heard of a centiliter in my life. Okay, so then it'll be 0.8 divided by 1,000. So this will then be 0,0008 milliliters. Guys, you need to get used to these conversions. Can we have a thumbs up, thumbs down? Thanks for checking my answer, Angela. I always appreciate that. Wonderful, wonderful. Okay, and now starts the problems. The inside of an Olympic-sized pool is to be painted on the inside. Calculate the surface area that has to be painted. Now, there's a few problems here. What do I first need to do, though? What do you think I first need to do over here? We have a couple of problems. Let's try and identify them and fix them. Convert. Which units do you think would be ideal to work with here? Do you think centimeters is more ideal, or do you think meters is more ideal? Butlala says convert your meters to centimeters. Okay, interesting. What does everyone else say? Okay, guys, imagine you are the person painting this, right? Do you agree that if everything is in centimeters with all these thousands, imagine I say to you, my pool is 15 million centimeters cubed. Is that an ideal unit to work with? Do you guys that think that is an ideal? Do you see what I mean? So sometimes you must look at the scenario, right? So it would be better to convert it to meters because of the size of the object you're working with. Okay, does that make sense, guys? In the same way, okay, let me ask you guys this. If I said I want to buy paper to wrap a gift, okay, which unit do you think would be more appropriate to measure how much paper? Would it be in centimeters or millimeters or meters or kilometers? Okay, Elam says centimeters. Okay, it depends on the gift, right? But I think generally maybe between these two. Because it doesn't make sense to say go by 0,004 kilometers of paper. Do you guys see what I mean? So a lot of these questions need you to like apply like logic and just think about, does this make sense? So let's convert everyone to meters because we're talking about a pool here. And it doesn't make sense that I am going to calculate stuff using a pool. Okay, centi. I'm going back to my centi. Centi, guys. Firstly, am I timesing or am I dividing? I'm going to a bigger unit, so am I timesing or am I dividing? Divide, that is true. And centi is the only unit that has how much? How much am I dividing by? Think of a century. Thank you, Butlale. By 100. So this will be 20 meters. This is so thin, I can barely see this. And this 5,000. Again, I'm also going to divide by 100, and this will be 50 meters. Great, isn't that better? We fixed the first problem. Now let's go on to the surface area. Now, I know you guys want to write down the formula the way you know it, but why am I not going to write the formula exactly the way I know it? What's different about this question here, guys? Think of painting a pool. Okay, how many surfaces did we say are in a rectangular prism? From the start, we were like, how many faces were in a rectangle? We said 6. Yes, Wandile, we said 6. So when you work out surface area with the normal formula, you are catering for 6 surfaces. Does a pool have 6 surfaces? Does a pool have 6 surfaces? No. How many surfaces do we have in a pool? Oh, Seth, beautiful. 5. Because the pool is not closed, is it? We need to be able to get in it. Like, imagine, like this is me standing over there and I want to jump in, but you have now closed this pool. Like, not good, right? Not good. So there are only 5 surfaces. Now, we need to figure out of that whole story of length, breadth, height, breadth, we need to figure out which one of those surfaces are we leaving out. So let's get going. What's my length in this case? Let's first identify the length. So, Wandile, think of a pool. Do you agree that if this is the pool, right, you're going to paint on the wall over there, you're going to paint at the back, you're going to paint this one, you're going to paint this one, and you're going to paint the bottom. Is there a top part to paint in a pool? Is there a top part to paint in a pool? No. Do you understand why it's 5? In a normal rectangular prism, there are 6 surfaces, right? There are definitely 6 surfaces, but that's because it's closed. But in a pool, we are leaving out the top. This red part, the top surface, doesn't exist because we need to be able to get in and out of the pool. Does that make sense? Okay, hopefully you're feeling better. Okay, length is my 50 meters. Can we get breadth, please? Which one is the breadth? Anybody? Thank you. This guy will be a 25 meters. And of course, your height will then be your 20 meters. Okay. So the surface area in this case, now this is going to be different. Okay. When I say length times breadth, am I accounting for the one in front and the back, or the one on the sides, or the one at the bottom? Length times breadth. Look where the length and breadth are. Are those the ones in front and back? Is it the left and right, or is it the one at the bottom? Length times breadth. Look at the picture. What do you guys think? Bottom and side. Remember, it cannot. Oh, you talk about dimensions. I was talking about the actual rectangles. But Seth, you are correct if you are saying it like that. But I'm talking about the actual rectangles. Botlale says left and right. So let's look at the blue triangles, which is left and right. Would that not be height because it's this dimension with your length, Botlale? That would be your height and length. So that's not the correct one, right? It is, if this is my breadth and this is my length, it's the one at the bottom. Do you guys see? Thank you, Dumi. It's the one at the bottom. And there's only one of them. So that's why I'm only going to say length times breadth. I do not need the 2 times because there's only one of them. Okay. Plus 2 times. Yes, this is the surface area. 2 times, if we look at the one Muhlale was talking about, which is left and right, it's your height and your length. Right? So height and length. Plus 2 times, if we look at the ones in front and back, that is your height with your breadth. Okay. After this is just substituting. So I want thumbs up, thumbs down. Do you understand where I get that formula from? Do you understand why the first one doesn't have a 2 in front of it? And can you identify where these rectangles are? You need to identify the proper length, breadth, and height here. Okay, this is why you cannot cram the formula because you need to look at it. Okay, it seems like everybody say they understand. So let's substitute. So 50 times 25 plus 2 times 20 times 50 plus 2 times 20 times 25. Great, let's get working. What's 50 times 25? 50 times 25, thank you, Bukhali. Plus, what's 2 times 20 times 50? I got a 2,000. Plus the last one, what's 2 times 25 times 20? 20 times 25 times 2 is, thank you very much, Bukhali, 1,000. You cannot afford to zoom out now. Okay, to zone out. Okay, let's add this. 1,250 plus 2,000 plus 1,000 is 4,250 meters squared.